Welcome to the Using Direct Edit in Mold Design. My name is Bill Mitchell and I will be doing the presentation today. This webcast is going to be done in SOLIDWORKS 2012, so we'll touch on a couple of the new features in 2012 as well as using the Direct Edit tools as it relates to mold design. Some of the topics that we're going to cover is leveraging the Direct Edit user interface queues to simplify your workflow. The tools are not anything that you probably couldn't do in a different method, but the direct edit functionality allows you to quickly move faces and check out and modify your model, especially imported data, without having to create excessive sketches that add to rebuild time. Um, so we'll go ahead and jump into SolidWorks and get started. So the first thing I'm going to do is open up a Parasolid file. And I'm using Parasolid because many times whenever you're doing mold design, you're getting a generic file from a customer, and they're going to want you to do a mold around it. Another way or another reason that you might be using a neutral file format is that your design is locked down and you don't want to modify it. There's a new tool in SOLIDWORKS 2012 called Freeze or Feature Freeze, and so the necessity to lock down your design isn't nearly like what it was in previous releases. So um, in any event, we'll just kind of cover some things. So I've imported this Parasolid and run the diagnostics, and everything seems like it's okay. Go ahead and switch views. And what I'm going to do is a mold split on this part, and then show you how to use some of the direct editing tools to do some mold design stuff. Uh, if you right-click on your command manager, and if you don't typically see your command manager, you can go to View, Toolbars, Command Manager, and that brings up the ribbon toolbar. If you right-click on it, direct editing is a tool, and these are features that are typically considered direct edit features. Things like move face, moving, copying bodies, adding fillets and chamfers to what are effectively dumb solids or imported bodies um, are considered direct edit tools. Another thing that is considered a direct edit tool is Instant 3D. Instant 3D allows you to select a sketch and basically modify it on the fly without having to get in and edit the dimension. You can just kind of pull on the handles and it'll update the model. So we'll cover that as well. So as far as the mold design goes, let's go ahead and create a configuration, and we're going to call this mold design, or let's call this mold. And this is going to be the configuration that is going to contain all of our different mold features, and then we'll rename the default to maybe production part. For the purposes of this webcast, we're not going to worry about assigning a material, but just in keeping with standard mold practices, um, we got the production part. I'm going to go ahead and add a scale feature, so I'm going to come over to mold tools, scale, and what the scale feature allows us to do is create a shrink factor because our molds are typically larger than the production part, and we'll put in a shrink factor of maybe 6,000. Um, so now the part has been scaled up, and then at this point we typically want to lock down the design. Um, Now, one example of using direct edit inside of a mold is say that the customer comes back, they've sent you a model, and then they come back with a revision and say, we want to move a given face around or something like that. Rather than have to redo your work, you can use direct edit in conjunction with this. So let's go ahead and get some work done on the parting line, and then I'll show you how to modify that. So coming over to mold tools, do a parting line analysis. I'll go ahead and select my top plane as my direction. Do a quick draft analysis. It finds parting line around the edge. Keep in mind this part is obviously lending itself to an easy parting line just because of the example nature of the part. So now I've got a parting line feature, and then I'll go ahead and select my shutoffs. It's found those three holes as viable shutoffs. And then I'm going to take my parting line feature and create the parting surface. Now in SolidWorks 2011, they added a feature called manual mode to your parting surface. And what this allows you to do is kind of change how the parting surface gets radiated from the model. So you can see I've got these little um, vertices at the nodes where a given edge stops. If I want to maybe say this is going to be 4 inches, maybe not that much, say maybe 3 inches. I can take the nodes and drag them out, and you can see how it changes the way that the surface gets projected. So for example, that face would probably be a little bit difficult to machine, so we'll just kind of snap it around to where it's something that's a little bit easier to machine. Another thing that they added in the same release is the ability to create a surface fill. So you can see that my surface as it radiates out gets a little bit odd. Typically you would want to go in and patch that with a surface, but if you right click on that node, you can do a surface fill before the surface is even completed, and that gives you a much smoother surface without the witness line that might show up in your G code whenever you go to machine that. Okay, so I've got a pretty clean surface, and the next thing I want to do is create a sketch for the size of my insert. So I'll use a rectangle, go ahead and assign some dims. Say it's going to be 4.95. Okay, so as I mentioned, I'm going to go ahead and create tooling split, select my sketch. That looks about right for what I'm wanting to do. Maybe make this an even number. I'll say 1.5 to zero point 0.7. So now I've got a reasonably simple mold. I'll go ahead and hide my body. And take a look at this. So I've got those faces in there. Coming up to my solid bodies folder. Hide my production part. And then show the other half of the mold. Hide my surface bodies as well. Okay, so that's basically what my mold looks like. So as it relates to some of the new features in 2012, let's go ahead and cover that, and then we'll get back into the direct edit stuff. So say I have a change that a customer comes back and says, you know, I want to move this face. So I can use direct edit rather than re-import and have to redo that work that I just did. I can come over to the direct editing tab, select move face, and what this allows me to do is translate a face. I can offset it, translate it, or rotate it. Offsetting in the context of moving faces is typically better because it will take the natural flow of the surface or the direction and offset it. So say that they come back and say, you know, I want this to be 95 thousandths longer. And so what that does is adds a move face feature, moves that down, and then whatever taper was happened to be on that face was there. I didn't have to go in and try to find out the taper or the draft on the face. I didn't have to create a sketch or anything. So the rebuild time on this feature should be a little bit faster than creating a sketch, extrude, all that type of stuff. And there's also not a witness line there, so that's a benefit of using the move face. And I'll do the same thing on this bottom face. I'll say that maybe these bottom faces are going to move out just a little bit. And maybe the arc of that face stays the same. And we'll say that's going to be, I'm just kind of picking numbers at random, I'll say that's going to be 60 thou. So by using the rollback bar, I can come back up, go ahead and configure these features because I do want those to be part of my production part because that is the change. So I'm going to configure those so that they are not suppressed so that my production part reflects the change that the customer requested. And then I can come back, redo my tooling split, and everything should update accordingly. So now in SOLIDWORKS 2012, they added a feature called feature freeze. By default, this bar is not turned on. So if you go to your options, general, and then enable freeze bar, what that's going to do is make this appear, and then I can come down at any point and freeze my features. So what that does is puts padlock, the icon changes, and so then that prohibits any rebuilds. That's kind of like it's very similar to locking a reference in an in-context design. So if you create a sketch or something that is in reference to another assembly, you can lock the reference so it prohibits updates from coming through. In the same way, the feature freeze doesn't rebuild. This is also going to be useful for complex sketches. So if you've got a logo or something that's an extruded feature that you know is going to be fairly static and you don't want to update it, or you don't want to go through the rebuild time every time you do a rebuild, um, the feature freeze will do that. Now, should there be a change, it does flag you. We do have some more information on this feature and its usage in the What's New 2012 webcast, but it seems kind of relevant to mold design, especially whenever you're dealing with files from another user. So I'll go ahead and turn off my parting line again. And then I'm going to go through and create some folders to organize my solid bodies. So I'm going to add a folder, call this production part. I'm going to add another folder called mold. That way I can quickly jump back and forth. So I'm going to hide this, show that, and so now I'm back into my mold. I'm in the mold configuration, and so I'm good to go. So the next thing I'm going to cover is using the Instant 3D, which is considered an aspect of direct editing. So again, go into features, make sure that Instant 3D is turned on. But what this allows you to do is if I come over to my tooling split and look at that sketch, you notice how if I look at the ends of the extension lines, I have these little blue balls. I can left click on this, drag it back and forth. So if I want this to be a different value, it updates automatically. So there, and you can always just left click on the dimension and say, I really want this to be 7.98. We don't want to have to grind off as much material. That also updates it. And the way that you get to this, you can select the face, and it also shows the extrude. So whenever Instant 3D is enabled, you get the ability to really kind of drill down without having to come over, edit the sketch, all this other type of stuff. So that's a pretty powerful way to quickly edit your models and save some time. If you get in the habit of doing it, I think you'll find that you like it. And a lot of users, when it initially came out, were a little bit gun shy about unintended changes, but it's something that's more of a matter of training than anything else. So I guess the next thing we should probably do is take a look at making the pins on this mold. So I'll go ahead and hide this one. So I'm going to do is make these pins. One, I'm going to add a little bit of crush to where it actually slides into the mating mold half. Then I'm also going to split these out because typically pins like this are going to be high wear areas wherever there's a shut off. So I'm gonna split these bodies. If I come back over here, create a sketch, go to a wireframe or hidden line mode so I can see what's going on. I'm going to wake up the center of that pin, touch it, grab the center. Typically I want these two to be the same size just to standardize the mold creation or the tooling. Then I'll add a dimension. Say that maybe this is going to be 0.79, 745. So now I'm going to take those two circles that I've created and I'm going to split out those cores. So coming back over to my mold tools, actually I'm going to do it this way, insert, create a split. I'm going to select my sketch, cut my part, so it gives me my 3 resulting solid bodies. I want to go ahead and keep all of those. Then I'm going to come back, hide that sketch. So now I've got 3 different bodies, one for the main body, and then those 2 cores. Switch back to a shaded view. Now I'd mentioned that I want to add some crush to the inside of this. So I'm going to coming again back over to Direct Edit. I'm going to use my Move Face, and I want to move these faces in. So I want a 1/8 inch of engagement. Well, it's got to be from one of the things with Move Faces. It does have to be from separate bodies, or you can't do multiple bodies at the same time. Move Face. So now if I come in and look at my other body, do some organization on this. Go through and do a section view. Another new feature in SOLIDWORKS 2012 is the ability to keep the cap color. So if I have my caps set to, say, maybe I want it to be blue, I can either retain that or I can go back to the original material color. So if I say keep cap color, it's going to remain blue. And you can see how I've got interference here. Again, coming back into this, if I want to turn that off, it's going to retain the color of the actual mold halves. So whichever way you prefer to do it is fine. But I do need to relieve some material from this side, so I'm going to, again, go back in, create a sketch, switch to a wireframe mode so I can see the inside of this mold. And then I'm going to create 2 circles. Make them equal to one another. And then also make those co-radial. So in practice, you typically want to add a little bit of slip fit to this, and so I'll show you how to use Move Face versus calculating it. Go ahead and put a cut in, features, and then extruded cut. Change the feature scope. Looks like I made a mistake, so I need to go back in and add this one. So I'll come back in, edit this sketch. Make those items co-radial. Okay, so now I've got some engagement in here. May want to break the edge of those, so I'll hide this body, and then add a chamfer. Use my copy paste feature. Select the one feature and then just do Control C, Control V. That way I don't have to enter the value in multiple times. So now if I want to change material for each one of these, I'm going to make this back into my materials. Add a material for each one of these guys. Oops, wrong one. And then for the opposite side, I'll make this a little bit of a different material just so we get even wear. We'll call this, well, I should have 4140 in here, but I'll say it's 4130. Okay, so now I've got a somewhat realistic looking mold. So now as it relates to using Direct Edit again, I'm going to go ahead and create some pockets or some heels for those pins. So again, I'm going to come back in, create a sketch. And you'll notice that what I'm doing is purposefully implementing symmetry in the sketches and then using move face to move the faces in versus spelling out the dimensions directly. And the value in doing this is that it always um, gives you the same offset, regardless of how the size is. And obviously, there's other ways that you could do this with a dimension, but if you use move face, regardless of how or what size it is, it's always going to be offset the amount that you specify. Probably should make this 1 point. There we go. Again, come in, make these guys equal to each other. And then I'm going to cut this in, so I've got a heel for my pins. Make this 0.255. Notice I oops, changed my feature scope. To just be that one part. That way I don't include the pins. So I should probably key those. I forgot to do that. So I'm going to edit my sketch. I'm going to add a line. And then use my trim tool. To put those in. So now if I come back in, you can see that I've got a pin or a pocket for a pin. Now because the inside of this, let me isolate this body. Isolate. If I rotate this, because the curvature of this inside face is such that the pins could get confused and then cause an odd shape, I need to key the inside of the pin. So again, coming back over to direct edit, move face, offset. I'm going to select that face and I'm going to offset this 20 thousandths so that one pin will not fit into the other pocket. At the same time, I'm going to go in and add a little bit of a chamfer. So now coming back over and looking at my pins, what I can do is use the convert entities tool. So I'll add a sketch. I'm going to convert that heel. So yeah, the surface, change my feature scope to just include this pin. Then do the same thing on this side. So since this is a size on size fit, I want to isolate this. And I want to add maybe a little bit of clearance. So again, I'll go back into direct edit. $20 thousandths offset so that it fits a little bit better. Same thing. So now my pins have clearance, but they are flush against that back face, and that is the type of thing that I would typically handle with tolerancing. So that's a basic part of my mold. So now, say if I ever want to make a change to this, and again, this comes back to the instant 3D functionality. I can select, if I select a sketch, you can see that it's done by convert entities, so I need to come back upstream. If I want to change the size of that, maybe the size of the heel, and say that, eighth or 100th thou ended up being too much, I can always double click on it. If I make it 63 thousandths, everything updates. So it's almost, it's a real time saver to use the direct edit tool. Another new thing in SolidWorks 2012 is the ability to explode subassemblies. Or I'm sorry, explode multi-body solids, just like you would in assembly. So if I come over to my configuration, because this is a part file, I can right-click on this, say New Exploded View. So I'm going to grab my pins, grab my part, my top mold half. And so I've got a pretty quick view of my mold. So then the next step would probably be getting these items prepared to be machined. Because we're in a single part file, more often than not, we want to be able to send these parts out on their own. Depending on what CAM system you're using, perhaps it would support SolidWorks and SolidWorks configurations. Something like CamWorks obviously does. So what we can use is the direct editing capability to separate these things out and then orient them correctly for how we want them to be aligned for machining. So let me go ahead and collapse this, and let's take a look at, we'll make some derived configs on this one. We'll call this core or cores, call it singular for the core block. Cavity block. And then we'll call this one pin. So now I've got my configuration set up. So we'll call this one pin 1. This one's going to be, or as we'll say this is pin 2. I'll work backwards. So what I want to do with this is I want to be able to delete these bodies. So everything other than this one, I'm going to say delete solid, and I want to delete these 3 solids. So that's created a delete body feature. If I come back over to my feature tree, see I've got body delete. If I come back over to my other configuration, for to rebuild, all the other items are there. But I probably want to come back over to pin 2. I probably also want to be able to orient this in a way that makes sense for my machining operation. So for example, if I want to orient this, I want to take this body and move it. I can grab the handles here, rotate this around. Also put the value directly in. And then I also want to move this to where it's on its origin. So I want to translate it. And to do this, let me back up a step. I need to create a sketch here as a reference point. So I'm going to create a sketch point. And then I can use move copy, translate this body from that sketch point. And I want to translate it to my origin. Do the same thing for this one. So I come back over to pin 1, delete solids. So I'm going to do the inverse of this. Rotate this body. Come create a sketch on this back face. Have another move copy, so I'm going to translate this body from that sketch point to my origin. So my core block. It's going to be this guy, so I'm going to delete those 3 items. And since this one is already at, come back up to my feature tree, 0's at the bottom of that, maybe I want to move that face or move it up to where that 0's on the bottom of this. So I'm going to run command, move, or say if I want that to be 0, I'm going to touch off on that as 0. Select move copy body. I want to rotate this around. And another way to do this would be to create setups in CamWorks. But if you wanted to do each one of these separately, I guess that's the point of showing this. I'm going to move this guy, translate from that vertex to 0, 0. So now I've got 4 different configurations with 0 at the appropriate spot per the operation. You can see the different pins. The slope of that is really what changed. So that's a quick look at what you can do as far as the configurations go. One final thing that is typically a good idea to do as far as mold design goes, or as large parts go, is also to create a folder in your feature tree so that you can see which items go to what. So I can say that this is the mold design. So I've got a pretty clean feature tree. I've got organization in my solid bodies folder, and then the surfacing tools that come with molds automatically adds that information in there. So go ahead and save this out. Go ahead and isolate this feature. Now, one of the things that's kind of peculiar about this is you can see that there's a face here. So we'll go ahead and take a look and see what we can do to repair that. So one of the things that you do need to keep in mind whenever you're using the direct edit tools as far as relocating bodies, if I come back down to my core block, if I come in and try to edit anything on this, it's going to, because of the way that the feature tree is organized, it's going to come back and edit the feature in its original location. So because my move body, or I'm sorry, body move copy feature is down here, if I edit a feature, it's going to be at its original location. So do keep in mind that the direct edit features, as far as relocating native SolidWorks solids, does retain the original location. So in that regard, it's good because it keeps any in-context designs and those types of things solid. But also, it can be a little bit confusing if you pick it up and kind of come down and need to make a modification. So, for example, if I delete this face, may delete both of these. I'll just delete one of them to illustrate my point. So if I select this, notice how when I select that edge here, there's an orange edge that pops up at this point. So that's its original location prior to the move body copy. So rather than do that, I'm going to come back to my original mold configuration. That way I can clearly see what's going on. I'm going to hide this, and then I'm going to delete those two faces. And the reason I'm doing that is because that artifact on the face doesn't exist on this side. There is a difference, but the tangency didn't quite work out. And you'll see this a little bit from time to time with parting lines. That's something that could very well come up on the G code. Leave a witness line that would not be desirable for the mold, something that would have to be polished out. So I've deleted that face. Now I've dissolved this into a surface body. You can see through my model. I'm just going to borrow the reverse face. So I'm going to come over to my surfaces toolbar, create an offset surface of this geometry. Say that it's 0. So now I've got the surface over here. I'm going to create a pattern. I'm going to mirror around the right plane, and then the bodies I want to mirror. Come to my surface bodies folder, or those two bodies, and you can see that it's basically mirrored it over to the other side. And then I need to do some trim work, so I'm going to trim up my surfaces, maybe do a mutual trim. Sections to remove, I want to clip off that section out here. So now I've got an exact representation of what's going on the opposite side. So in just keeping my surfaces clean, I do want to come back in, right click these guys, delete body. So now I've got a delete body feature, and again, that's one of those direct editing features. So now I've got my original delete face feature, which is the core block, and then I've got a couple of faces out here. So I'm going to come back over to my surfaces, knit these guys up. And a lot of times I've found with surfaces, rather than try to select a geometry directly from the graphics window, selecting it from the feature tree often gives you a better result. I'm going to use gap control. You can see that I've got a little bit of a gap. It's not much, down to 1,000, but that would make a difference. And then try to form a solid out of the closed body. And that's it. So now that witness line has been removed. And again, it's one of those things you could do with other tools, but using the direct body or the direct edit functionality and access to that toolbar is definitely going to make things a little bit easier for you. And I'm going to do some cleanup. And so now I'm in my top level config. And that's it. So hopefully you learned something, or learned to use some tools that might be useful to you in creating molds with SolidWorks. If you have any questions, go ahead and email us. The email address is support@ddicad.com. Thanks.